Topside power isn't perfectly stable, is it? Generators trip, fluctuations happen, brief outages occur all the time. Let's dive right into this explainer and look at the invisible engineering that keeps subsea assets alive. We spend so much time talking about the massive hardware sitting on the seabed, the trees, the manifolds, the pipelines, but none of that hardware moves, communicates, or operates safely without a continuous, highly reliable pulse of electrical power. Today, we're exploring the subsea power supply system. So what actually happens to a multi-hundred-million-dollar asset when the topside power sneezes? We've all been on a host facility, right? You know that generators trip, switching transients hit, and power fluctuates constantly. It's just a reality of industrial offshore operations.
Well, you lose control, literally. Think about it. If subsea comms and control power went down every single time that platform grid blinked, you'd completely lose visibility into your asset. Every time someone sneezes on the platform's electrical grid, you risk losing control authority over safety-critical valves sitting thousands of feet underwater. That is the exact problem subsea power supply engineering solves.
Let's look at quality versus availability. Here's what a lot of folks actually miss: power quality and power availability. They are not the same thing. You need two entirely different pieces of hardware to tackle them. Think of the setup behind a critical hospital server room. On one hand, you've got the EPU, or electrical power unit. That's essentially your industrial surge protector, making sure the power feeding your sensitive gear is squeaky clean. On the other hand, you've got the UPS, the uninterruptible power supply. That's your battery bank, keeping things alive during a blackout until the backup generator kicks in. You absolutely gotta have both.
Let's dive into the EPU first, regulating the supply. Before we even worry about the power dropping completely, we have to deal with the messy power first. The EPU sits topside, takes that raw, fluctuating platform power, and conditions it. And listen, this regulation isn't just some nice-to-have convenience. It's a hard requirement. Subsea electronics, especially those logic circuits inside the subsea control module, are way more sensitive to power quality than your standard topside industrial gear. They literally cannot handle dirty power or random voltage spikes.
So, to condition that topside power before sending it all the way down the water column, the EPU supplies dual, isolated single-phase power. It shoots that right down the composite service umbilical. Inside the EPU, you'll typically find a DC bus bar tapped for energy storage alongside an AC line that provides a direct feed to the Subsea Electronics Module, or SEM. This meticulous conditioning is absolutely crucial to prevent frying those expensive subsea modules.
Next up, the UPS, riding through outages. All right, so solving power quality with the EPU is great, but what happens when the topside power just straight up drops out for a minute? Enter the uninterruptible power supply. The UPS is designed to maintain your comms and control continuity through those host power drops. And let's put some real numbers to this. Subsea UPS systems are generally sized to bridge interruptions on the order of minutes, not hours. Their main job is really just to survive typical generator trip and restart cycles without you losing control communication. Now, a super common and dangerous design shortfall is failing to properly size the UPS to bridge the platform's typical fluctuation time. If that ride-through time is too short, the battery dies before the main generator even recovers. And what happens? You end up losing control visibility exactly when you need it most, right in the middle of an upset condition.
Which brings us to the high stakes of sizing. Managing the power draw across a subsea field is, honestly, a massive balancing act. You've got to balance small, continuous loads, like the SEM drawing a max of 80 watts, or sensors pulling about 50. But then, boom, you have these crazy intermittent spikes. Actuating a single valve might just pull 10 watts for 2 seconds. But when the hydraulic power unit pump kicks on to recharge the accumulators, that thing demands a massive 11 kilowatts for a couple of minutes. The EPU and UPS have to seamlessly juggle these wild load variations without dropping the baseline communication voltage.
So pause for a second and really think about this scenario. Imagine a busy offshore platform. A main generator trips. It takes exactly 30 seconds to get the backup spinning and power restored. If you decided to skip putting the UPS in the loop, what actually happens down on the seabed?
Well, here's how that chain reaction builds. At 0 seconds, the topside generator trips. At 2 seconds, the subsea control module completely loses comms and control power. By 10 seconds, depending on your fail-safe design, the system realizes it has no control and the safety valves automatically slam shut as a precaution. At 30 seconds, the topside generator restarts. Power is back. But guess what? It's too late. Without that UPS, communication drops instantly and the whole subsea system overreacts.
You've just triggered a massive, multi-million-dollar unplanned shutdown, along with all the hydrate risks and restart headaches that come with it, over a measly 30-second topside hiccup. Ouch. But with a properly sized UPS, you prevent that massive overreaction entirely. By just bridging that tiny 30-second gap, it saves the whole operation from a totally unnecessary fail-safe closure. It quietly provides the ride-through power, keeps the Subsea control module status lights nice and green, and the Subsea system doesn't even realize the platform had a power issue in the first place.
Let's wrap this up with a quick Subsea power summary.
Here's the main takeaway you need from this explainer. Topside power is inherently messy. It will always fluctuate and trip. To actually protect your subsea asset, you have to solve two completely different problems. The EPU solves power quality, acting as a voltage regulator. The UPS solves power availability by bridging brief outages. If you only solve one, you are leaving the field totally vulnerable to the other failure mode. You absolutely need both of them integrated into your architecture to maintain steady, reliable control.
You know, the best engineering is perfectly silent. When an EPU and a UPS are designed and sized correctly, nobody on the platform even knows they're working. Which kind of makes you wonder, with so much incredible complexity sitting right there on the seabed, what other invisible systems are preventing offshore disasters right now? Think about that. Until next time, keep exploring the engineering beneath the surface.